This is the brief on how bridges hold heavy weight. Today, we're boiling down dense engineering guides to reveal the completely invisible forces keeping massive bridges from catastrophically collapsing during our daily commutes. First, every bridge has to deal with two primary forces: compression and tension. If a bridge can't transfer these forces safely, well, it's gonna buckle or snap. Just think of compression like squishing down a metal spring, and tension? That's kind of like two sweaty teams pulling on a tug-of-war rope. Second, how do engineers actually handle these massive pushing and pulling forces? They use geometry. Triangles are literally their ultimate secret weapon. See, pressing on the top point of a triangle pushes the force evenly down its sides and stretches the bottom, which prevents it from bending. This is exactly why you see trusses, those triangular latticeworks, on so many bridges. Now, you might ask, why not just use massive solid steel blocks? Well, solid beams are just way too heavy and expensive. Truss shapes give you maximum strength with minimal material. Finally, what happens when the gap you need to cross is too wide for standard trusses? Engineers scale up to suspension bridges, like the famous Golden Gate. Heavy traffic pulls down on thick cables, that's your tension, which then push down on massive tall towers, that's your compression, spreading the weight safely. But get this, bridges also have to survive the environment. The mind-blowing Tacoma Narrows Bridge literally swayed for hours and collapsed just months after opening, all because the wind caused aeroelastic flutter. Ultimately, a bridge's survival relies on using geometry to perfectly balance pushing and pulling forces. Join our next session where we'll explore how helicopters stay in the air.